Okay, guys, I'm going to do this extra practice packet for you. I'm not going to do this first page because you can scan the QR code and watch a video yourself. So I'm going to skip to this page. Okay, which of the following could be the equation of the quadratic shown below? So what you want to keep in mind is that when the a is negative, sorry. So when a is negative, it's going to be upside down. And because of that, you're going to eliminate choices 2 and 4 when a is equal to a negative. So now I'm going to focus here on the y-intercept, and the y-intercept is positive. So it has to be choice D. Okay, based on the quadratic function shown in the table below. So remember that quadratic functions have this symmetry. So you got the 9 matching with the 9, the 3 matching with the 3. And you can also use that to help complete a table. Like, for example, if I covered the 9, I would match it by knowing, okay? And this is called the vertex or the turning point. Okay, so you use the vertex or the turning point in order to find the range. The range is y. And it's going to have an 11, so it has to be this one. Why is it less than? Because just look, 9 is less than 11, so less than. Okay, and there's always an equal bar. So this says for problems 3 to 5, use tables on your calculator to help you investigate. So you're going to use your calculator, okay? So now maximum means that x equals 3 is at the top, so 3 comma something, okay? I could always add the arrows, why not? All right, so I'm looking at all of these, and I'm going to eliminate 1 and 4 because those would have a minimum. So I'm going to try choice 2, and I'm going to type it into my y equals. Okay, so I type into my y equals negative 4x squared plus 24x, subtract 21. Second graph is table. And if I look on my table, it's 3 comma 15. Can you see that, I hope? 3 comma 15. So this is correct. Okay, which of the following will have a minimum value of negative 5 at 7? So that's going to be the vertex, okay? So since it's a minimum value, it cannot be 2 or 4. So I'm going to type this into my calculator, and I'm going to type option 3. Y equals x squared, subtract 14x plus 44, second table, second graph is table, and 7, negative 5 is indeed the turning point. Okay. All right. So which one has an axis of symmetry of x equals 6? So it's 6 comma something. So I'm going to type that in. Y equals the negative of x squared plus 12x, subtract 11, and it's 6 comma 25. So it has to be choice 2. All right. I'm actually going to skip this question because it is repeated. So I'm going to go right here. Okay. All right. So multiply. That would give me 12x to the third, subtract 8x squared plus 12x. That's the distributive property. Okay. So I'm going to do the x squared. So that's x cubed plus 5x squared. Now I'm going to do the negative 3. So that's negative 3x squared. And that would be negative 15x. And now I'm going to do the 5. So plus 5x plus 25. That's the distributive property. So x to the third plus 2x squared minus 10x plus 25. And that's called combining like terms. Okay, factor. So I'm going to use a GCF. So I pull out the 5x, and what's left is x subtract 3. I'm going to pull out the x squared. What's left is 4x to the 6th minus 9. That's the difference of two squares. So 2x to the third minus 3, 2x to the third plus 3. Difference of two squares. So x squared goes in both. And now factors of 12, so 1 and 12, 2 and 6, or 3 and 4. I'm going to use 3 and 4. Okay. X, 15. So 1 and 15, or 3 and 5. I'm using 3 and 5. Okay, so this is called stretching. So you're going to do 3x squared, and I'm going to use minus 5x and plus 3x minus 5. Okay, so why did I choose the 3 and the 5? Because 3 times 5 is 15. And I'm looking for factors of 15 when added, give me a negative 2x. So I pull out an x, I get 3x minus 5. I pull out a 1. I get 3x minus 5. So I get x plus 1 times 3x minus 5. I'm going to pull out the GCF of 4. And then that is also the difference of two squares. So x plus 5, x minus 5. All right, simplifying. Perfect square, other guy. The perfect square gets simplified, or you find the square root of the perfect square, and the other guy just stays. All right, so perfect square and the other guy, so 2 radical 30. Perfect square and the other guy, so 8 radical 2. Perfect square and the other guy, so 5 radical 3. You can check these on your calculator by typing in the square root of 75. You'll get a decimal, a non-terminating, non-repeating decimal because it's irrational. And then if you type in 5 radical 3, you should get the same decimal. Okay, solve by factoring. So first I'm going to set it equal to 0. So that becomes 2x squared minus 6x equals 0. GCF is 2x. Pull it out. So that gives me x equals 0 and x equals 3. Solve by factoring. So first I'm going to set it equal to 0. So x squared minus 4x minus 12 equals 0. So x subtract 6, x add 2 equals 0. So x equals 6, x equals negative 2. And again, you can check these on your graphing calculator. Okay, solve by completing the square. So x squared plus 8x, leave a space, equals 3. So I want this to be a perfect square trinomial. So I'm going to add 16 to both sides. I got the 16 by doing half of 8 is 4, and then 4 squared is 16. Okay, so that's x plus 4 squared, that's factored form of the perfect square trinomial, equals 9. Oh, sorry, equals 19, that's a 16. So x plus 4 equals plus or minus radical 19. So 4 plus or minus radical 19, negative 4, because I moved it to the other side. And then you would type that in your calculator in order to get answers to the nearest tenth. You would type it once as negative 4 plus radical 19, get your answer, and then type it again as negative 4 minus radical 19. Okay, so set this equal to 0. 2x squared plus 6x plus 1 equals 0. Quadratic formula is on the reference sheet. x is equal to negative b plus or minus square root b squared minus 4ac all over 2a. Okay, so x is equal to negative 6 plus or minus over 4. You have to take 6 squared in your calculator. You take the whole discriminant, b squared minus 4ac, in the calculator. You should get 28. They want simplest radical form, so we're going to break the 28 into 4 and 7. So that gives me x is equal to negative 6 plus or minus 2 rad 7 over 4. Okay, graph and identify all of the following. Okay, so I'm going to put that in my calculator. Okay, so delete y equals x squared, subtract 5x, and then add 4. Okay. Second graph gives me the table, and I would use my table. I would definitely use from negative 1, 10, so 0, 1, 2, 3, 4, 0, 4, 1, 0, 2, negative 2, 3, negative 2, 4, 0, 5, 4, and 6, 10. Okay, so you would plot those points on a piece of graph paper, graphs go on graph paper, and you connect to form a parabola. All right, so they want the axis of symmetry. So the turning point is right in the middle of here. All right, so that means that it's going to be 2.5 or 2.5. You can actually change your table by hitting second window, which is table set, and you could start at 2.5, and then that would tell you that the y value is negative 2.25. You can definitely use your calculator for that. So axis of symmetry, x equals 2.5, because it's always the x value of the vertex. The end behavior, this parabola you will see on your graph paper is going up, so the end behavior would be considered increasing. The y-intercept is when x is 0, so the y-intercept is at 4. The x-intercepts, those are the roots or the zeros, and that happens at 1 and again at 4. The average rate of change from 3 to 5, so that's just slope. So change in y is going up 6, change in x is going up 2, so the average rate of change is 3. Okay? Of course, you would do this on graph paper. All right, solve graphically. So I'm going to go to the graph again. Y equals x squared, subtract 2x, add 1. And I'm also going to type negative x plus 3, graph. Okay. You can clearly see that it's intersecting in 2 points, 2 places. Okay? So you're looking for those 2 points. So on your graph paper, you would graph the parabola. You would graph the line on your graph paper. You would graph both of those. And then you would look for these 2 points of intersection. Okay? You can copy the table from the graphing calculator. Okay? And let's just say I'm going to go from negative 1, and this is 4, 4. And I'm going to do 0, 1. And I'm going to do 1, 0. And I'm going to do 2, 1. And I'm going to do 3, 4. This is a point of intersection because it's shared. And the other point of intersection, -1, 4, and 2, 1. So when you answer this question, you have to write the ordered pairs. Whoops. 2, 1. Okay, and remember this is done on graph paper. Okay, solve algebraically. So you're going to set them equal. Since they're both in y equals form, it's pretty easy to set them equal. All right, so I'm going to move everything to set it equal to 0. Okay, move everything to set it equal to 0. I'm going to multiply everything by 2 so I don't have to deal with the fraction or decimal. And there's an x here. So that's 2x squared minus 9x plus 4 equals 0. So 2x squared minus 8x minus 1x plus 4 equals 0. Pull out a 2x, I get x minus 4. Pull out a -1, I get x minus 4. This is factoring by splitting. So I get 2x minus 1 and x minus 4. So if I solve this one, I get x equals a half. And if I solve that one, I get x equals 4. But I'm not done because I also have to find the y value. Half of a half is a quarter. So it's going to be 2.25. So this is going to be the point 1/2, comma, 2.25. Half of 4 is 2. 2 plus 2 is 4. So this is going to be the point 4, comma, 4. And you can absolutely check that on the graphing calculator. All right, number 9. Type that in. So we have -16x squared plus 64x plus 80. Okay, so I have 0, 80. I have 1, 128 around here. I have 2, 144, and then back down. Oops, that one should be here. And then 4 is back to 80, and then 5 is 0. So it's going to look like this. Okay, what is the maximum height? It's at the vertex, so that's 144. What time does it hit the ground? 5 seconds. When is it increasing? It's increasing from 0 to the turning point, so it's increasing from 0 to the turning point. Okay. All right, so a few bonus things for those of you that are taking the time to watch the video. All right, so I'm just going to try to bring up a whiteboard. Let me see if I can do that. Not so sure I can. Okay. Smart. I'm hoping you can still see this.